By using the continuity properties, we can solve some inequalities. Actually, one of the basic tools for analyzing graphs in calculus is a spatial line graph called a sign chart. We will make extensive use of this type of the chart in the later sections. In the discussions that followed, we use continuity properties to develop a simple and efficient procedure for constructing sign charts. Let's look at the following example. Suppose that a function f is continuous over the interval 1 and 8, okay? F is continuous on the interval 1 to 8. And f of x not equal to 0 for all x. For all x in the interval 1 and 8. And suppose also f of 2 is 5, for example. F of 2 equals 5. So, which is a positive number, okay? This is the important part. If it is negative, it can be changed a positive. It is impossible for the function f of x to be negative for any x in the interval 1.8. The answer is no, it is not possible. If f of 7, for example, let's look. What we know that on the interval 1 and 8, the function value f of 2 is 5. So our curve passes through to this point. So it is not intersect the x-axis. So if you start from the somewhere here, negative value, graph is like that one. So without tracing current, if you sketch this graph, there is a 0. Or here, if your graph starts like this one and goes to negative value somewhere here, again it has a 0. Or in another case, start here and you pass to that point and go down and go up again. You have the two zeros here. The function is the 0. But we know that f of x is not a 0 here. So it is not possible to take the negative value. Okay. Your textbook explained it a different way. Maybe it's more mathematical. Let's assume if f of 7 were, for example, minus 3. 7 is arbitrary chosen, okay? Just as a example, counter example, 1, 8. So f of 7 is minus 3. Let's assume some negative value. Maybe not at the point 7, at the point 6, 5, 1 over 1.2, some number between the 1 and 8, okay? On the other hand, we know that f of 2 is 5. So, how would it be possible to join the point 2, 5, this point, and 7, minus 3 with the graph of a continuous function without crossing the x-axis? Okay, actually it is not possible. So if you sketch the graph, so maybe if there's a jump, so this is discontinuous. By the continuous case, it is not possible. So as a result, we conclude that f of x must be positive for all x in the interval 1.8. Okay, let's write f of x must be positive for all x in interval 1 8, which is belongs 1 to 8. In general, if f is continuous and f of x different than 0 on the interval a, b, then f of x cannot change the sign of a and b. So if f of x is negative, for example, as this value is negative, f of x is always negative. If this value is positive, which is on the interval, 2 is on the interval, so f of x value is positive. So when making the sign chart, we use that fact. Okay, so let's write this important fact. This is important. If f is continuous, and f of x different than 0 on the interval a, b, then f of x can change sign on the interval a, b. To create or to find such intervals is easy. By finding the partition point, I will give what is definition partition point. You can find these intervals easily. Let's look at the following theorem. This is the sign properties on the interval a, b. If f is continuous on interval a, b, and it is repetition 0 for all x belongs to a, b, then either f of x is bigger than 0 for all x in a, b, or f of x less than 0 for all x in a, b. So when it is negative, when f of x is positive, you can determine by choosing the arbitrary test point on the interval. Okay, in the lecture, by making sign chart, you will understand this fact actually. And also, in my opinion, in the high school, you learn how you can make the sign chart. Okay. So this theorem provides the basis for an effective method of solving many type of inequalities. Okay, when it is negative or when it is positive. We can solve a question, but actually we will use this fact in the sign chart. Now I can give the definition how we can create the we can create these intervals. Okay, so according to this definition, or not this definition, maybe you need the procedure, but first of all you need this definition. A real number x is a partition number. We define a partition number. Partition number for a function f if f is discontinuous at x or 0. So maybe it's a jump or discontinued at the point, and maybe it is 0. Okay, so in the previous case, let's turn back to that idea on the interval 1 8. If it is not continuous, it is possible to have the this graph negative value. For example, this is 2, this is 7, this is 7, this is minus 3. So it is possible to sketch this graph, for example, like this one. Here there is a jump discontinuity at the point, for example, 6, and it continues like this one, okay? So this is discontinuous. So you cannot use the 1-8 interval. You can use the 1-6 interval first for the analyze, and you should use the 6-8 interval for the being negative or positive case for the function f. So suppose that P1 and P2 are consecutive partition numbers for f. So that is, there are no partition number in the open interval P1, P2, okay? So here, this is the one partition number P1, this is second partition number P2. Maybe we have the another partition number P3 somewhere here, okay? But anyway, for the two consecutive partition numbers for f, we can say that f is continuous, and also if f is continuous on the P1, P2, okay, we can say that f does not change sign on the interval P1, P2. So either this is positive, so the graph like this one, or the graph like that one. Maybe it can be increasing or decreasing, but anyway, for example, this is also possible. That is also possible. But anyway, either function is positive or negative. In other words, partition numbers determine open interval on which f does not change sign. This is very important. Partition numbers determine open interval on which f does not change sign. By using a test number on the interval P1, P2, we choose some test number from each interval. Okay, we can construct a sign chart for f on the real number line. It is then easy to solve the inequalities f of x is less than 0 or f of x is bigger than 0. Okay, so now we can summarize how you can construct the sign chart. So this procedure, in the lecture I will use this procedure. So given a function f, it does not have to be continuous, okay? But by finding the partition point, we can find the several intervals on where f is continuous, okay? So first step, first of all, find all partition numbers of f. So f of x is 0 or discontinuous where. So find part A, find all numbers x such that f is discontinuous at x. For the rational function, discontinuity point are the x value that make a denominator 0, and b, find all numbers x such that f of x equals 0. For the rational function, actually this means numerator is 0, but if at the same time denominator is 0, this is not in the domain, okay? So maybe it's not continuous there because it's not definite, okay? So it's first case also hold here. Second step, step 2. Plot the numbers found in step 1 on a real number line. This procedure is very important. So in this record, I will solve an example. Dividing the number line into interval. Step by step, I will apply this procedure. And third step, select a test number in each interval, in each open interval. Determinant in the step 2. And evaluate f of x at the test point. Why we need this one? To decide the sign. Number to determine whether f of x is positive or negative in each interval. And last step, construct a sign chart using the real number line in step 2. This will show the sign of f of x on each interval, each open interval. Also, we will use the sign chart for the derivative function. In the future, you will see how we can use that one. Okay. Also, there is an alternative to step 3 in the procedure for the constructing sign chart. That may save time if the function f of x is written in the factored form. The key is to determine the sign of each factor in the numerator and denominator of f of x. We will, in the examples, we will illustrate, okay? The partition number, okay, let's look at the example. Which example, what should I use? Okay, let's look at the following example. F of x equals x plus 1 over x minus 2. Our aim, for example, to solve this inequality bigger than 0. But anyway, I will decide the all case. Step 1. So let's find the partition point A. X minus 2 equals 0. This implies x equals 2. So here f is discontinuous at x equals 2. B, when this is 0, f of x equals 0 implies x plus 1 equals 0, which implies x equals minus 1. So we have a two partition point. So minus 1 and 2 are partition point, okay? Partition number, not the point actually. Second step, you can look. Plot the numbers found in step 1 on the real number line. dividing the number line into intervals. So x, this is the real line, minus 1 to, okay, so these are our interval, minus infinity to minus 1, minus 1 to 2, 2 to infinity. So f of x at the point minus 1, this is 0, so we do not buy this one. At the point 2, not defined. Instead of the ND, sometimes I use the this one, okay, this means not definite. Or sometimes I use ND for non-definite case. So let's choose the arbitrary point as a test point as according to step 3. So step 3, on the step 2 I will show that. For example, point 3 here. At the point 3, this is 4 minus 4 over 3 minus 1 1. So this is positive. Okay, so f of 3 4 over 1, which is positive. So let's choose another test point 0, for example. F of 0 is 1 over minus 2. This is minus 1 over 2. That is negative. Here let's choose arbitrary point f of minus 2, which is minus 1 over minus 4, which is 1 over 4. So this is positive. Okay. So we make the sign chart according to the test point. Because we know on this interval either this is positive or negative. And construct the sign chart using the real number line in step 2. This shows us the sign of the f of x. Okay. So from that part, step 4, we can say that when f of x is positive, f of x is bigger than 0 for all x in interval minus infinity to minus 1 and 2 to infinity. Okay, here that's positive, here that's positive. F of x is negative for all x in the interval minus 1 to 2. So you can use this procedure to make the sign chart.